So, hi, good evening, good afternoon, and good morning and to all of you, depending on your location. My name is Amos, and I'm here to learn with you guys again on this my interesting journey on machine learning in data science. All right. So, and let me just tell you guys a bit about myself. My name is Amos, and I work as a health informatics officer for an organization in Nigeria called EQUS, and I actually um, play the role of a software engineer because I am very good with Java, Spring Boot, I write enterprise application, and we work on health informatics, EMR in Nigeria. So basically, I'm a software developer, but for some time now, because of where I work, I'm beginning to be very interested in machine learning and data science. So currently I am working as an intern for Edrica as well, but it's a paid intern, right? So it's not as if I'm working for them, but it's a paid intern. I'm basically paying to learn from their experience. So today I want to share my journey with them, what I've learned so far. So I'll be working on a classifier problem. So I'll be using K nearest neighbor classifier algorithm to be able to predict um, Irish um, species. All right. So this is a flower that has different categories. You know. So we have that set, and I'll be able to use that set to create a predictive model that will correctly predict a new data supplied to it. Will be able to tell us whether this data that is given to us belong to a certain species. All right. So that's what I would like us to work on, and let me discuss how I got the data set. So there is this um, um, website that is called Cargo. If you are into machine learning or data science, you will know that Cargo has a lot of data set that you can come, download, and play with. So I'm doing basically the same thing, and I'm interested in this flower because it's very beautiful. As you can see, purple colors, yellow colors, as the case may be. It's a very interesting plant, and we could learn a lot from this um, species, but I'm more interested in trying to create a predictive model that will basically predict a new data that's supplied to it. So this is a classical example of supervised learning, all right, because the target is also provided for, so we can use the label to learn from the features, which are basically the independent variable. All right. So let's go into it. All right. So I have downloaded my sklearn and my pandas and matplot library because I want to do some videos at the end of the day. So let's start, right? So let me import this. So now I have the libraries available in my Jupyter notebook, and then let me read the data set. Yeah, so this gives us an idea of what this data set is all about. And as you can see, the data set looks good to me, but there is a problem. Okay, a typical problem that we'll have when we pick data from anywhere. So in this case, it's not major, but can have a great impact. So if you look at the species color, which is our target variable or the outcome, you will see that it is not in a numeric format. And that's a problem because we cannot feed in um, categorical data set or categorical variables into our model. It requires numeric variables. So we have to transform that column into something that the model will be able to understand. And how do we do that? For us to achieve this, we need to use a label encoder, an encoder. So basically what an encoder does for us is it transforms categorical data set into numeric variables. So in this case now, let me import the encoder. Now let me run this species, right, so that we can see the categories that are available. So we have the setosa, versicolor, and virginica. So these are basically the species. They are free. All right, so these are in categorical format and not good for our model. So I have to now transform this into something that our model can understand. So I call this encoder fit transform on the species column, and this will basically encode this into numeric format. So I have done all this and reassign back to the species column. So when you run the data frame again, you will see that nothing happens because I have not run this. So let me run this. Yeah, so once I do that, you will now see the effect here. All right, but for you to have an understanding what exactly goes on here, I'll still run this same command. I will run over here and you will now see the difference. So this has been transformed to 0, 1 and 2, and that corresponding to the setosa, the versicolor, and the virginica. All right, so now our model can understand numeric value, and that's exactly what we want to achieve. So my next step will be to split my data set into to be able to separate the features from the target. Now why do I need to do that? I need to do that because I will use the features to train my model, and while training the model I need to separate my features. So, and you also know that features are what we call independent variables. So we usually denote them by X, which is the independent variable. So to do this, you can quickly achieve that in Python by just dropping the species column from the original dataset and assigning it to X. And if I run this, you'll see that this data frame does not have the species column, and that's exactly what we want. This becomes the independent variables that will be trained to give us the expected outcome. Now I also need to keep my expected outcome because I'll be using it to also feed the model, and the model will learn using this dependent variable. It will be able to give us a dependent variable, which is the target target. So now we have this data set separated. The next thing we want to do is I want to have an idea of the data that I have. So I have about 150 columns here. Now this is just to have an idea of the size of my data set. Now the next step for me will be to try and split the data I want to train, the one I will use for testing, and so on. And the good thing is that sklearn have all this already for you. You don't need to do anything. You just need to just import it and use out of the box. So I imported the train test split from sklearn model selection, and I have it handy. So let me run that so that you see. Now I have to pass in my independent variable and my dependent variable and specify the test size. So it is a standard practice to always use 20% of that set for testing and 80% for training of your model. I want to stick to that because it's basic, right? So, but this method, this train test split returns a tuple, and this tuple comes back in this order. You have the x train, the x test, and the y train and the y test. So this is like you having 4 variables. The x train is 80%, the x test is 20%, and the y train is 80% of the data as well, and the y test is 20%. If you want to check this, you can confirm here. Now this is 120 of the records, that's about 80%, right? And the test will now be 20% of the remaining, let's say. So we use this for training the data, the model, and we use this for testing, as the name depicts. The same thing is applicable to the target variable, as you can see. So far this is good. Now I don't know if any of you paid attention to this data set. You will see that we have 5, 3, 1.4 and 0.2. If you take this standard deviation by row, you will discover that this data is spread, and we are making use of nearest neighbor, and the internal algorithm for nearest neighbor make use of the distance of the data points to be able to measure the closest neighbor or synoid or point or cluster. So if the features are widely spread, that can be a problem. One of the features that has a larger number will end up bringing a bias effect on the model. So you want to scale, you want to bring it to a standard scale. Now scaling means that you bring the data to the same standard, right? Same scale. So good enough, we also have the standard scaler that is also handy in sklearn. So I already imported it over here. So now I want to scale my data so that I can train. Now to do that, I have to create an instance of the standard scaler, and then I call this chaining method fit transform. This can different function, but you know Python is very flexible, so it gives you this ability to chain these methods together. So I'm calling fit and transform on the train data set. Now what this does in the background is it will calculate the fit will calculate the standard deviation and the mean deviation of this trend data set that we have set aside the 80%. And then when you call transform, it will go through the data set and apply the value of x minus mean all over the standard deviation to all the values in that column. And now you will now see that it will now bring the scale very close to each other for you to make a better prediction. So without transform, that will not apply. Without the fit, the standard deviation and the mean won't be calculated. It's very important to know what is happening. So you can see this is what we have after this exercise. So we have scale of data. Very important. Now on the test variable, we don't need to calculate the fit. Why? Because the standard deviation and the mean was already calculated when we call it on the train data set. And the train data set has more numbers, 80%. If you take the standard deviation or the mean from that data set, that gives you an idea of your sample space. Alright, so you will know that what you have is within this category range. So you don't need to calculate that on a small data set, which is 20% of the sample space. So this already gives you an idea that this is where your data falls. So you only need to transform, do the x minus this mean all over the standard deviation. So it will make use of the standard deviation that was already calculated as well as the mean. I hope that makes sense. And of course you are doing that on the x test, because if you don't do that, again the test variable should not be on the same scale with the trend data set, so the model won't understand when you try to test or to predict. That will not make sense. So again, it's very important for you to also scale this data. So again, this has been done, but again, wait a second, why am I not applying scale on the target variable or the independent? You don't need to do that, right? Because already we have 0, 1 and 2. The distance is very close, and of course they are just labeled telling us this, so you don't need to do that, just to make sure that we are on the same page. So again, I will run I'll run that so we can see. So now is the model proper, so I need to create an instance of the KNeighborsClassifier, and again you need to specify the number of neighbors that you want to classify, right? So for me, I just give 3 basically, because maybe there are 3 species, but that is not the idea, alright? But I just want to put 3 so that I can have an idea of what I'm doing. So create an instance of this model, and then I need to train it, pass my train, and pass my the trend that's set, right, for the x and y variable. So I run this, and now my model has been trained. And what is it doing? Basically learning, trying to to calculate the distance between each of these points, the columns, the fixtures, and draw them to the nearest neighbor. So it's learning what? The cluster. That is what is happening here. So once that is done, it's for me to make my prediction. And here we go. This is the prediction. Now, how do we measure our model, the performance of this model? Now, if you are using a linear regression model, for example, you could make use of square, mean square, error, mean square, error, or yeah, a lot, there are a lot of measures you can do there, but you can't do that here, all right, because this is a classifier problem. So here we make use of what is called a confusion matrix. As the name depicts, it's frustrating for me to understand this. And what do you mean by a confusion matrix, right? So basically this is used to measure classifier models, right? It creates a matrix that shows whether the model was able to do what is expected of it. So, but let's ask ChatGTP, right? So I asked ChatGTP here that what is confusion matrix, and this is what he has to say. Confusion matrix is a table used in classification to evaluate the performance of the predictive model. It summarizes the result of the classification problem, showing the number of correct and incorrect prediction made by the model compared to the actual outcome. You get an idea, but it's basically used. So let's see how we can get it. So again, we can import it from sklearn matrix, and then we have it, and then we'll run, passing in our actual or the test variable and the prediction. Remember, this is the same, just that this is a prediction and this is the actual. So if you run this now, it will give you something. Now I won't be interpreting this, but I'll give you as an assignment. You go and find out. But what I can tell you is that looking at this is saying that my model is great, is doing, is good based on these values that you can find out and tell me whether I'm lying. All right. So put it in the comment for me, but this looks very good to me. So the next thing is, let's see how we can visualize this prediction that we have done, so again I will import my seaborn. I love seaborn. It's very great tool for visualization in Python. Then I also need this decomposition, because when you do prediction, the data might be in another structure, maybe in HD, and it's difficult for you to be able to visualize. So this will bring it back to the standard that you can visualize. In this case, I'm trying to bring it back to 2D so that I can visualize on my two-dimensional array, so that I can visualize. So when I run this now, you will see the idea. Beautiful. So you can see that this is clustered around 3 neighbors, right? 1, 2, and 3. And then you can see that each of the species is represented with color. Purple, is this green? Yeah, green, and then yellow, right? So you can have an idea. This is the species group, and this come out to look very good. So you have an idea of how this is done. So thank you guys, and for your time. Drop your comment for me in the section for me to improve, and let's find something to learn from it, and let's keep working together. Thank you once again for your time. Thank Edrica for the wonderful work they have been doing on me. I really appreciate it. Thanks and over, guys. Bye.